I'm Zafran from CSE department. I'm going to explain you the experiment of implementation of K-means clustering for customer segmentation in introduction to ML. We are going to see about the introduction to clustering, objective of the experiment, implementation of the program, and execution and result of the experiment, application of clustering, and the conclusion, final conclusion. What is clustering? Clustering or cluster analysis is a method of grouping entities based on similarities, defined as an unsupervised learning problem that aims to make training data with a given set of inputs but without any target value. We are going to group the set of inputs by the target values. It is the process of finding similar structures in a set of unlabeled data to make it more understandable and manipulative. In simple words, these clusters are group of like objects that differ from the objects in other clusters. That means the grouping of objects that going to be differ from the other clusters. And then objective of the experiment. The main objective of this experiment is to segment customers into distinct groups based on the annual income and spending score using the K-means clustering algorithm. The goal is to identify patterns in customer behavior such as distinguishing high spending customers from low spending ones. We are going to distinguish by annual income, that is going to be high spending customers and low spending ones, and they'll be assisting targeted marketing or personalized services for different customer segments. So then we are going to see about the implementation of the program. Let's break down the code step by step and explain each section. Firstly, import necessary libraries. A pandas SPD imports the pandas library for this is pandas SPD imports the pandas library for data manipulation and the analysis. Matplotlib pyplot is for importing Matplotlib for creating visualizations like plots and charts for graphs. Okay, then load and inspect data sets. pd.read underscore csv. This is the file, CSV file. This function reads the CSV file containing mall customer data into a pandas data frame called data. This is PD. And data.head function displays the first 5 rows of the dataset to get a quick look at the data. And the data.info function provides a summary of the datasets, including the number of entries, column names, data types, and null counts. And then data.isNull dot sum function checks for missing values in the datasets by summing up the null values for each column. And then the third step is implementing the elbow method for k-mean clustering. From sklearn.cluster import k-means, which imports the k-means clustering algorithm from the skid.learn. And then WCSS function initiates an empty list. This is an empty list to store the within cluster sum of squares. That means WCSS, within cluster sum of squares, for each number of clusters. And then the loop, which is for I in range 1, 11, iterates over a range of clusters numbers from 1 to 10. K-means, which is k-mean n underscore clusters equals to I net equals to k hyphen means plus plus. Initiates a k-means model with I clusters using the k-mean plus plus. Initiates as k-means model with I clustering with k-means, which helps in choosing better initial cluster centroids. And then k-means.fit function fits the k-means algorithm on the data starting from fourth column. For example, annual income and spending score. WCSS.append k-means.inertia appends the inertia sum of square distance of the nearest cluster center for the current number of clusters for the WCSS list. WCSS means within cluster sum of squares. And then plot plot function plots the WCSS value for each cluster, counts from 1 to 10. That means the n value will be n minus 1. 11 minus 1 will be 10. So 1 to 10. And then plot.x label number of clusters, labels the x-axis as the number of clusters, and plot.y label the plots the y-axis as WCSS, and the title sets the plot title to elbow method, which helps in determining the optimal number of clusters by identifying a point where the WCSS decreases significantly. And then the fourth step is applying k-means clustering with 5 clusters. Km initializes the k-means algorithm within 5 clusters. I have given it here as 5, so it will be 5 clusters. Km.fit fits the k-means model on the data starting from the 3, and then also means there will be fourth column, from the fourth column. And then the y underscore means predict. Km.predict predicts the cluster labels for each customer in the data sets to the data frame, which stores the customer label for each customers. And then data clusters means adds a new column clusters to the data frame, which stores the cluster label for each clustering. And then the fifth step is segmenting customers into clusters. DF0, DF1, DF2, DF3, DF4 creates a separate data frame for each of the 5 clusters. I have already given here as 5 clusters, right? So I have taken 0, 1, 2, 3, 4, 5. That means 5, 0, 1, 2, 3, 4 create separate data frames for each of the 5 clusters by clustering the data, by filtering the data where the clusters column equals to clusters column will be equals to 0, 1, 2, 3, 4. It will be separates the data frame as per this condition. And then the sixth step is visualizing the clusters. Plot.scatter c equals to color and label equals to cluster. I have given each of the clusters to be in a different colors and the unnamed as different clusters. Plot the clusters using a scatter plot. It will be in a scatter. I have given it as scatter, so it will be in a scatter plot for annual income on the x-axis and spending scores. It is in x-axis. It will be in spending score will be in y-axis, on the y-axis with the different colors representing each color. Cluster 0 will be red, cluster 1 will be black, cluster 2 will be blue, and cluster 3 will be green, and cluster 4 will be magenta. And plot that legend adds a legend to the plot to label each cluster. And in plot the title we have already given as cluster, right? So here they have set it as, for the plot they have set it as customer segments. Set the title of the plot to customer segments, indicating that the cluster represents the different segments of customers based on their spending behavior and annual income. And the output is, I have already told you, right? Here it is given and the plot is plotted over here for the number of clusters and WCSS, and this is will be the elbow method. And then the scattered plot is over here for customer 0 red and customer 1 black, customer 2 blue, customer 3 green, and customer 4 magenta. And it has plotted here over here. And then result elbow method plot. By plotting the WCSS value for clusters, counts ranging from 1 to 10. The elbow method helped identifying 5 as the optimal number of clusters. Here 5 as the optimal number of clusters. And then the plot shows a significant decreases in WCSS as the number of clusters increases, with the elbow appearing at 5 clusters, indicating that this is a reasonable trade-off between compactness and cluster updation. And cluster assignment. The k-means algorithm divides the customer into 5 distinct clusters based on their spending behavior. For cluster 0, it is low. This is low income and low spending customer. And for black, the cluster 1, high income and low spending, and blue, average income and average spending customers. And or cluster 3, high income and high spending customers, and cluster 4, low income and low spending customers. And then applications of cluster, there are so many applications of cluster. I have listed 3 over here, very important 3 over here. And if you want to know some more, you can briefly know it from Google or Chrome in so many platforms. And firstly, market based analysis. Clustering can be used to group products that are frequently bought together, leading to insights on product bundling benefit. Helps in creating product bundles, improves cross-selling strategies, and designing store layouts. Image segmentation and compression. Clustering can be used to segment images into different regions. For example, foreground and background, detect objects, or even reduces image size by grouping similar pixels. Benefits: enhance image understanding, aids in object detection, and improves storage efficiency. And biological data analysis, genomics. Clustering is used to group genes or proteins with similar expression patterns. This helps in identifying groups of genes involved in specific diseases or biological processes. Benefits: aids in understanding gene function, diseases diagnosis, and drug development. And then conclusion. In summary, the program successfully segmented customers into distinct clusters, and the visualization clearly highlighted the different customer segments, providing insight into their spending patterns and income level. And that's it. Thank you.